In this video, we'll discuss about isoenzyme. What is isoenzyme? How to define? Isoenzymes, they are different form of same enzyme catalyzing the same reaction. So, they are different form of same enzyme catalyzing same reaction. Take one example, lactate dehydrogenase. Lactate dehydrogenase, there are various isoenzymes. LDH, lactose dehydrogenase 1, 2, 3, 4 and 5. Each LDH 2 or 3 or 4, it catalyzes conversion of lactate into pyruvate. NAD plus is required as coenzyme. This converted into NADH plus H. LDH, lactate dehydrogenase 1, 2, 3, 4, 5. These are the various isoenzyme catalyzes the same reaction, that is conversion of lactate into pyruvate, but they differ with their properties. For example, they differ electrophoretic mobility. That is why they are known as isoenzyme. Now coming to how they are formed. There are 4 terms which are important. One is true enzyme, second one is lactate dehydrogenase, third one is isoform, fourth one is allozymes. So 4 important terms: true isoenzyme, lactate dehydrogenase, isoforms and allozymes. First one is true isoenzyme. When they are originated different genes, they are known as true isoenzyme. What is true isoenzyme? They originate different gene, and this gene may be presented in different chromosome. It presented in different chromosome. For example, amylase. It has 2 forms, pancreatic amylase and salivary amylase. So it is an example of isoenzyme originated from different gene and located on different chromosome. Second is lactate dehydrogenase. There are 5 lactate dehydrogenase enzyme, 1, 2, 3, 4 and 5. All isoenzyme are all variant. They are present in some individuals, and this is presented in all individual of that population. These 5 variant is presented in all individual of the population. Next one is, third one is isoforms. Isoform means they are produced due to the post translational modification in the protein. So this one produced due to post translational modification of protein. For example, alkaline phosphatase. There are various example of alkaline phosphatase. It is due to sialic acid content or carbohydrate content in alkaline phosphatase. It gives 6 isoenzyme of ALP. It is due to the post translational modification of protein. Next one is allozymes. They are originated from the different alleles. They originated from different alleles of the same gene. They are originated from different alleles of same locus of the gene. They are known as allozymes. Example, glucose 6-phosphate dehydrogenase. There are nearly 400 isoenzymes of glucose 6-phosphate dehydrogenase, and only one variant is presented in one individual. One variant presented in one individual. This is how they are formed. Now coming to some characteristic of isoenzyme. Isoenzyme catalyzes same reaction, but some properties are different. So first one is electrophoretic mobility. For example, LDH1 moves fast in electrophoresis as compared to LDH5. LDH5 is the slowest moving component. This one LDH1 fastest moving component. Then second one is heat liable, stability to heat. The hepatic variant alpha 2 heat liable is presented in liver. It is sensitive to the heat. Third one is various inhibitors. Tartarate liable acid phosphatase. Then fourth one is cofactors. Different isoenzyme required different cofactor. For example, isocitrate dehydrogenase, the mitochondrial variant, it is required NAD as a cofactor, while cytosolic variant required NADP as a coenzymes. Fifth one is sensitive to antibodies. Its different isoenzymes are sensitive to different antibodies. Sixth, tissue of origin. For example, there are 6 isoenzymes of alkaline phosphatase: bone, liver, intestine, biliary, placental and mucosal alkaline phosphatase. Seventh one is Km value and affinity. These are the characteristics which differ from each other. Now coming to the examples. There are 3 classical examples. LDH, second one is creatine kinase, third one is alkaline phosphatase. So first one is LDH. LDH, there are 5 isoenzymes, LDH1 to 5. It is a tetramer composed of H and M unit. LDH1, it is made up of all H4. LDH2, it is made up of H3 and 1M. LDH3, that is H2M2. LDH4, HM3. LDH5, it is made up of M4. These are the subunit LDH1 to 5. This H4 variant mainly presented in heart. The normal condition concentration of LDH2, it is 35% of total LDL activity, means it is highest concentration. LDH2 and followed by LDH1, that is nearly about 27%. But in myocardial infarctions, the concentration of LDH1 increased as compared to LDH2. That is known as flipped pattern of LDH. So it have that name, flipped pattern of LDH. This component, that is LDH1 H4, is the fastest moving in electrophoresis. This M4, LDH5 M4, this one is the slowest moving component. LDH1 is the specific marker for myocardial infarction, but it is late marker, means it started rising after the attack 6 to 12 hours of the attack, which is at peak 24 to 48 hours, and return to the normal in 6 to 10 days. It comes to the normal. And now coming to isoenzyme, this one of that creatine kinase or creatine phosphokinase. Creatine is converted into phosphocreatine with the help of CK1, CK2 and CK3. These are the three isoenzymes. There are dimer composed of M and B unit. CK1, it is composed of BB unit. CK2 composed of MB unit. CK3 composed of MM unit. The concentration of BB increase in brain infection or brain disease. The concentration of M and B, it is the specific to heart. It is earliest marker for myocardial infarction, earliest and enzymatic marker of myocardial infarction. It start to rising 3 to 6 hours after attack, which is peak in 12 to 18 hours, and come to the normal 36 to 48 hours. So it is important in diagnosis of myocardial infarction. Then MM unit, it increase in muscular disease or muscular dystrophy. So this is about CK, creatine kinase. Same reaction, but they differ in electrophoretic mobility and their component. That means BB unit, MP unit, MM unit, and tissue of origin, brain, heart, and muscular dystrophy. Coming to third, alkaline phosphatase enzyme. There are 6 isoenzyme of alkaline phosphatase depending upon their carbohydrate content and source of origin. First one is this one based on their electrophoretic mobility. First one is alpha 1 presented in biliary tree. That concentration about 10% of total activity. Alpha 2 heat liable in the liver, 25% of total activity of alkaline phosphatase. Then alpha 2 heat stable, this is placental origin. Then fourth one is free beta from bone and constitute about 50% of alkaline phosphatase. Then gamma, it is presented in intestine. Then last one is leukocyte alkaline phosphatase. This is in leukocytes. So these are the 6 isoenzyme. Alpha 1, alpha 2 heat liable, alpha 2 heat stable, free beta, gamma and leukocytes alkaline phosphatase. 6 isoenzyme of alkaline phosphatase. Now the clinical importance of alkaline phosphatase is there is increased activity of alkaline phosphate near about 2 to 3 times of normal. The normal range is according to the kit 30 to 300 international unit per liter. Slightly higher level are found in children or growing age. Increasing in alkaline phosphatase activity, it is seen in hepatic disease, that is viral hepatitis. Increases alkaline phosphatase level 10 to 12 times of normal. It indicates that obstructive pathology, means obstructive jaundice and Intrahepatic cholestasis increasing 10 to 12 times of normal. 2 to 3 times normal means hepatic disease, increasing 10 to 12 times means obstructive pathology. So this is clinical importance of alkaline phosphatase. Thanks for watching.